Hello, I'm Mr. Raz, and today we'll be doing periodicity. This is video 2, the sequel to video 1. And we'll be looking at cast diagrams. So I remember this with the saying all stations to Croydon, and that's hence the pictures. So all stations to Croydon helps us remember these quadrants. Yes, we imagine you just draw quadrants and you put ASTC, spells out the word cast, hence it's often called a cast diagram. I call it all stations to Croydon because I like it that way. So this helps us remember what's in yellow. Yeah, so from video 1, and the graphs are on the left of the screen, they are periodic for those amounts in yellow. So periodic means they'll repeat. Yeah, so sine repeats every 180 minus theta, tan repeats every 180 plus theta, and cos repeats every 360 minus theta. So what we do is, first, I put a theta in here. Then, I always measure anti-clockwise. So if I'm dealing with sine, that would be there. Yeah, so that's my original angle, and this would be my second one. If we're moving anti-clockwise, how do we get to this blue line from here? Hopefully you realize we do 180 minus theta. Similarly, if I go to tan, if I'm measuring anti-clockwise, so I measure from the horizontal line, always the horizontal line, I measure up. So from here, I think we agree that would be 180 plus theta to get to tan. So if I put this line in cos, like that, seamless. This is supposed to reflect being the same similar angle, but it's not. It doesn't have to be that accurate. Yeah, and so we measure from the horizontal. So I went from here to there, and then we go this way, anti-clockwise. What will that angle be? 360 minus theta. So a cast diagram helps you remember what's in yellow. So you could argue there isn't a huge need to draw the graphs. Sometimes it's very useful to get the final solution. 100% with a negative range, the graphs will help. But this will help you for 75% of the work or type of question. But what I ignored there was negatives. And this is what I make a mess of explaining to people. Yeah? Because you can't do a GIF fix in real life. Yeah, so my live version is just full of mistakes, so, full of me saying things that when I thought I said something else. So if we put this in here, for negative, measure into the wrong quadrant. All right, so let's say we're dealing with sine, then, and that with theta, then if I follow my own advice, I think that would be the wrong quadrant. And that would be the wrong quadrant. Yeah. Not only do we measure into the wrong quadrant, we measure the wrong way. So instead of going anti-clockwise, we go clockwise. So this negative solution would be negative theta, and then we'd have the negative of 180 minus theta for sine. Yeah, which is what we found when we did the graph in video 1. So if I do cos, then the wrong quadrant to cos would be tan and sine, obviously. Don't know why it took so long to think about that. So we measure from the horizontal line. Yeah, and then we measure the wrong way, so clockwise. So that first solution will be 180 minus theta, and the second one will be 180 plus theta. Yeah. And that will give you your other solutions. And then for tan, that will be sine and cos. So we'll get there. So negative theta, and we would have negative theta. The second solution would be negative, open bracket, 180 plus theta. Yeah. And cos, we do cos, that would be in the sine quadrant. This would go there. And that would be that way. But I don't know why I bother doing cos, because that's so easy. It's a even function anyway. So cast diagram helps us remember these. So when we're dealing with the right-hand side of the graph, the positive values, we use the formulae in the yellow. That sums up the periodicity. And when we're going into the negative region of the graphs, we use what's in green. Some of you find it easy to draw the graph. Some of you find it easy to cast diagram. Yeah. Why not use both? Anyway, I hope you've enjoyed that. I've been Mr. Raz. See you soon.